So today, under the heading of alkenes, we're going to talk about polymers and the process of polymerization. So, what are polymers? Right, first to define them, polymers are large molecules built up of many small units called monomers. Okay, Sobia, what does mono mean?
Two.
No.
Wait,
Yeah,
one.
one. Right? So this means one. And any idea what poly means?
Two. Three.
No,
Man, English like a
no.
chain of monomers.
It just means many.
Okay.
Okay. And the mer part means something like unit, right? Or part. So a polymer is a large molecule that has many units, a built up of monomers which are single units. So single units join together to make a large molecule, obviously thereby having many units. Make sense?
Yes.
Okay. Now, generally what polymers have repeating units, right? Which means this long chain, right? The monomers are either the same or similar type of molecules. Okay, and that's why I'm saying repeating, because if you got the same thing again, 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 just it's a repeat, or they're similar at least, right? They have some similarity. There's some difference as well, but some similarity, right? And so you got that kind of molecule joined one to the other, to the next, to the next, to the next, right? And you can end up with a chain that is thousands of monomers in length, or maybe more, like tens of thousands or hundreds of thousands, depending. Okay. uh,
Yes.
how is this relevant to us? Have you ever heard of polythene?
No.
No. How about nylon or perspex?
Oh, nylon, yes.
Right, those are all polymers,
Okay.
right? And they're all, you know mm, let's say based, or pretty much like organic polymers.
Okay.
So what we're going to talk about, we're going to take an example of polythene. Now, judging by this name, which molecule, or wait, I wrote that wrong. Polythene. Which molecule do you think is the monomer?
Which what?
I'm Polythene is the name of a polymer.
Yeah.
What molecule do you think might be the monomer for polythene?
To be frank, no idea.
I kind of gave it away when I wrote it first. You missed that. Haram, any idea?
She has no idea either.
Are you guys like having a secret chat in the background?
No.
Okay.
Well, it would be better if you tell us.
Well, that's what I'm here for, obviously. Uh, Alright, so we talked about addition reactions yesterday, and for addition reactions, we talked about hydrogenation, hydration, and then halogenation.
Yeah.
What if you took an
Ethane.
ethene molecule? Oh, there you go.
Oh,
What if you
okay.
what if you took an ethene molecule and you added another ethene molecule to it? What's going to happen?
Polythene.
No, well, this is not polythene. Poly means many, right?
Isn't this many? I mean,
There's just two of them. I'm just giving you an example
okay.
to clear the concept. And so what's going to happen is you're going to lose the double bonds in both of these guys,
Well, yeah, obviously.
right? Because they're an addition reaction. And so
Wait,
you,
how many number do you need to exceed for it to say polythene? Like, should it be more than 2 or 3?
well, I mean, you have numbers that go up to 20 or 24 or something. You got numbers going up, and
No, like, what's the minimum?
yeah, your question is how many is enough to make it a polymer?
Yeah, exactly.
That's a good question. And all right, let me look it up. Right, so technically three.
Oh, okay. So 3 is the standard.
It's not the standard, it's technically the minimum.
Okay.
Why is it the minimum? Because
Oh, more than 3.
when you got three, right, it's sort of like plural. So you can say poly.
Yeah.
You could, right? Although you have the tri for it.
Yeah.
Mono di tri. I gave that yesterday, right? Yeah, tri. So I mean you got tetra and penta and hexa and all of those,
Yeah.
but so normally when they use the term poly, they're talking about like at least like uh, you know let's say for example 50 plus or 100 plus or maybe a few hundred molecules, because that's what you normally have in these type of large molecules, the polymers. So right, the technically the minimum is 3, but when we talk about polymers we're not talking about 3 only.
You're talking about more than 3.
Much more, much more. Okay.
Okay.
Now so what's going to happen, right? You're going to lose double because an addition reaction. So it's an addition reaction for both of these, right? Not just one. And so you're going to get a straight chain, right? And how many hydrogens do you have over here? You've got 8. So 1, 2, 3, 4, 5, 6, and 7, 8 hydrogens, right?
Yeah.
And so you've got this over here. And then, right, I mean, it's not going to stop over here. And you're not just adding 2. So what you're doing is you have ethene and you're using n molecules. Okay, where you're not giving a specific number to n just means a large number of molecules in this case. Okay.
Okay. Yeah.
And so you're using n number of molecules of ethene in an addition reaction, and what you're ending up with is right, you're losing the double bond, and that is a sign of an addition reaction happening. And so this is the monomer, right? This is what you started off as a monomer, but again, this is a complete molecule on its own. But when you did the addition reaction, right, this is
Yeah.
what the monomer looks like after the addition, right, and making the polymer. So then you write it off as, right, you leave these hanging ends that, there are other molecules attached,
Yeah.
and you put the N over here,
For addition.
which means that after the addition reaction, the polymer chain looks like an N. So this is N number of repeats of given monomer. So this is N number of monomers used in addition reaction, and this is after the addition happens, n number of repeats, because obviously, like, for example, you're using 100 molecules to start with,
Yeah.
then how many monomers will you have in the polymer?
Yeah.
How many?
Okay. And at least you need a 3.
No. If you're starting with 100
Yeah.
and you carry out an addition reaction with those 100 molecules and you form a polymer, how many monomer units, repeating units, will you have in the polymer?
8.
Beta, if you take
100.
exactly, right,
Okay.
you're going to, you have 100 molecules, you're doing an addition reaction. So how many repeat units are you going to? You're going to have 100 repeat units, right? You're going to have 100 monomers.
Credits to Haram.
Okay, I didn't hear it, so miss that, right? So simple, right? Now obviously we're talking about multiples of hundreds or thousands, right? And that's why we're giving n, we're not putting a number to it. I'm just saying 100 to explain it,
Okay.
right?
Yeah.
Now what happens with the hanging ends, because no matter how long the chain is, you're going to have these two hanging ends, and so they probably, finish off the reaction by adding hydrogen or something to, seal off these ends, because you obviously need a complete molecule. You can't have carbon with unbonded, ends, right? So, and again, as far as the syllabus is concerned, you don't need to worry about it. So how do you represent a polymer? You start off with this. These are the monomers that are unreacted. You write an N as the multiple, right, with that monomer in brackets. And then when you represent the polymer, you remove the double bond. You represent that with the new bonds left as hanging ends. And you write it N over here on the right side as a subscript, that they're N repeating units. Okay.
Yes.
So this is an example of polythene, which is a plastic that is widely used in many applications, right? So it's used, as an insulating material, or other stuff. Now this type of process, as you might guess, is called addition polymerization. Polymerization, right? Why? First of all, you're doing an addition reaction like we studied yesterday. Plus, another feature is you are getting only one product, which is the polymer itself,
Okay.
right?
Yes.
Is this clear?
Yes.
Yes.
Okay.
Like it would be better if you could explain addition polymerization again.
Okay. So there's have you heard of PVC? Ever heard of it? For example, the
Yeah.
pipes used in plumbing, PVC pipes,
Yeah.
right? That is uh, right an ethene molecule. So let's move on to the next page, right? PVC, which stands for polyvinyl chloride. And what does the molecule look like? The molecule looks like this. It's basically an ethene molecule, but right with one of the hydrogens replaced with a chloride. Now keep in mind that this has not been achieved by addition because the double bond is still there. You can see that the double bond is still there between the two carbons, right? So some other reaction conditions and some other specifications of the reaction, and one of the hydrogens was replaced with a chlorine, and so this molecule is called vinyl chloride. We're talking about PVC, which is polyvinyl chloride. So what are we going to do, right? This is how we're going to represent it. You have n molecules of this monomer, and this undergoes an addition reaction, addition polymerization, and now this is what it looks like. And you put an n to show, oh, there are n numbers of repeat units or repeat monomers in the vinyl chloride. So if I just draw it out, right? Let's see, 1, 2, 3, 4, 5. So I've got 10, right? And so these are the repeat units. I'm just highlighting them with a blue dotted line. So you got 5 of them. Technically, this constitutes as a polymer. And so what is it going to look like? You've got hydrogens and a chlorine. Hydrogen and a chlorine. Get it?
Yeah.
And so, right, this is whatever material you have that's made of PVC, this is what the PVC molecule looks like. And then you've got these ends that go on, and like they replaced a hydrogen in the ethene molecule with a chlorine atom, and it didn't disturb the double bond. They can obviously seal off these ends, and add hydrogen at the ends to have a complete molecule, sealed molecule. But I'm not writing that right now, right? So I'm leaving those ends open to show that the molecule is much larger than this. Haram? Sorry, not Haram. Sobia? Clear?
Yes.
That's not a very confident yes.
No, I mean, you were. Haram was the one who was confused. So I was fine.
You are fine, right? You're all good. I can ask you questions about this.
No. That does not mean. Okay.
So this is what now PVC is not part of your syllabus. It's given as a going further, but it's mentioned in your book, right? Another polymer that's mentioned is PTFE. Again, this is given as a going further thing. So this is poly tetrafluoroethene. So what do you think the molecule is going to look like? It's an ethene. So how many carbons are we going to get? You guys there? How many carbons will it have? It's an ethene molecule.
2.
2, right? And what does tetrafluoro tell you? How much is tetra?
13.
Tetra.
3.
Sobia.
Sorry. Yeah.
5?
4, 4.
4. Come on, guys. And what does fluoro tell you?
It flows.
It's not FLOW.
Fluoro.
FLUORO. Do you know any element that has like a similar name such as fluoro?
Fluorine.
Phosphorus.
Fluorine. And so this guy has 4 fluorines instead of the hydrogens. Right? This is what the molecule of tetrafluoroethene looks like. You want to make a polymer out of it, right? So n number of these monomers, addition reaction, okay?
Addition happening here.
So PTFE or polytetraphenyl fluoroethene or PVC polyvinyl chloride, right? Acha, uh, polyvinyl chloride is also known as polychloroethene, which makes more sense, right? It's an ethene
Yeah.
molecule with a chlorine, so chloroethene, which makes more sense, but it's also called vinyl chloride, so whatever. Again, both of these molecules are not part of your syllabus. They're going further. I just use them to explain the addition polymerization concept further.
Okay.
Okay. But again, right, they might throw some other molecule at you. And so as long as you understand the concept of what's going on, you should be able to handle it. Of course, practicing with past papers and developing that, concept further and all of that. Haram, all good, all clear?
Yes.
Okay.
But like, why don't we have a hydrogen in like PTFE?
Because they've replaced all the hydrogens with fluorine atoms.
Okay.
Now, how they did that? Like obviously, some process that is. I don't think they even mention how you achieve that. I'm not sure what A level. I don't think they do. I could be mistaken. But yeah, right. So you don't need to worry about that. In fact, you don't need to worry about PTFE at all because again, it's not part of the syllabus. It's there in the textbook if you want to read it, and they haven't given a lot of information about it. They just mention it as another kind of monomer that makes polymers. Okay, so if that's all clear, then right after that they have this environmental challenges of plastics, which I mentioned yesterday. That I leave that to you. They also, under the addition or the polymerization heading, they mention some of the uses of polyethylene. That it is tough and easy to mold, and it's a very good insulator. But right, it does not corrode, and you cannot dispose of it. It does not biodegrade, and places where it's used to make crates and wrapping film and boxes and plastic bags and etc etc, right? So that stuff you can just read. So I'm not going into that. I don't believe there's anything technical. It's kind of like going through a geography text, kind of, not exactly. And with that we move on to chapter 13, right, which is labeled as organic chemistry part 2. Okay.
Yes.
And also the third last chapter of our syllabus.
Okay.
Something?
Just thought that we could do it the next class, or that's fine.
You know what? We could, but given that we are almost through January, I would prefer that we focus on completing the syllabus first, right? So that at least we have our content with us. We won't need to rush through the content or have extra classes, stuff like that. I believe
That's
that that should be prioritized.
okay.
Okay, so the next chapter starts off by talking about functional groups, and we know that the functional group of an organic molecule so of functional group of an organic molecule is an atom or group of atoms that determine the chemical properties of the homologous series. Right, a homologous series, for example, alkanes, alkenes. We're going to talk about alcohols. We're going to talk about carboxylic acids, right? So uh, that, and as you know that alkanes don't have a functional group. In case of alkenes, it's not an atom or group of atoms, it is the double bond. There's another homologous series which is not given in O level, which are the alkynes, which have a triple covalent bond in them, right? And so that triple covalent bond will act as the functional group. Again, it's not in your syllabus, I'm just mentioning that. Okay, so we have a lot of different organic molecules that have many different functional groups that give them different properties, and also which end up, so what happens are these functional groups not only give them their chemical properties but also, right, take part in the reaction. I mean, you could have a reaction where you are not like that, you give the conditions such that the functional group is not taking part, but right, normally the functional group is the one that is the one that's being affected in the reaction. Okay, so some functional groups or homologous series with their functional groups uh, are, right, we've got alcohols, so that is a homologous series and they are represented as ROH. What's the R? The R basically represents the alkyl group. Alkyl group. What is the alkyl group? The alkyl group is basically the hydrocarbon chain. So for example, if you've got propanol, so you've got 3 carbons with an OH at the end. And so, right, whether it's 3 carbons, whether it's 2 carbons with an OH, right? In fact, even if it's just one, you can have methanol, right? Methanol, ethanol, propanol, and butanol. So you've got 4 carbons with it. In any of these cases, this part, right, generally, when you're not talking about any specific alcohol, is an R, which means the chain of carbons before the functional group. Does that make sense?
Yes.
So before
Yes.
functional group. Right, and it's not just with alcohol. So another thing that we will be looking at are carboxylic acids. So these are organic acids. You've come across hydrochloric and sulfuric and nitric and carbonic acid and all of those, right? And those are inorganic, right? These are organic acids. Why? Because they are acids that are hydrocarbons. And so, right, whatever length of their chain, what's the functional group? The functional group is a COOH, right, molecule. Or I shouldn't say it's a COH molecule, it's like a COH group. So, right, a group of molecule, a group of atoms, sorry, because it looks like this. You could consider as a molecule, I guess. Yeah, molecules are more. Yeah, yeah, sure, molecule. Okay. Anyway, then you've got something called esters, right? And what are these? These are, right? So there's a alkyl group or a hydrocarbon chain, and then you've got a C, and then two oxygens combined in a certain way, and then you've got another alkyl group, so another hydrocarbon chain coming on later, right? What do they look like? As in the molecule system, we will talk about them, right? We're just introducing ourselves to the different functional groups. Then you've got amines, and this is what they look like. R NH2, right? So you've got hydrocarbon chain and NH2 at the end. And then finally you've got amides, right? Which looks like R CO NH2. This table is given in your book. It's given on the first page of chapter 13. And right, you need to know these guys. Okay?
Yes.
Now with that, we move on to talking about alcohols. And again, we're talking about the homologous series that chemically have the OH group, right? And as I mentioned, I believe yesterday, this is not the OH, for example, the NaOH, which splits up as the sodium ion and the hydroxide ion. So this is not a hydroxide ion. This is an OH, and this is called the hydroxyl group. This is called the carboxyl group, right? So yeah, so we're talking about the molecule, the homologous series which has the hydroxyl as its functional group. So what is the general formula? The general formula is CnH2n plus 1 OH. Okay, so you have, yeah, something,
Yeah. No.
right? CnH2n plus 1, and then OH, as I mentioned, the OH is the hydroxyl, right? And you can also generally represent it as ROH if you're not talking about the exact number of carbons. So right, we have a single carbon alcohol. So how many hydrogens is it going to have?
CH2.
So be it. CnH2n plus 1. If there's one carbon, n equals to 1, then how many hydrogens is it going to have?
CnH2n plus 1. Wait. There is one carbon,
Uh,
two hydrogens. N is going to be for Cn, right?
N is the number of the number of carbons, and then right the hydrogens come in accordingly. Just like we've done CnH2n plus 2, you've done CnH2n for alkanes and alkenes.
There is one carbon,
Yeah, so that's N equals to 1.
and then there is H2n will be 2. N will be 2 since there are two hydrogens.
No, forget what I've made. Don't look at what I've made. Tell me how many hydrogens are there going to be.
2,
Are you sure?
3.
3, good. Right, because it's 2n. So 1 times 2 is 2 plus 1. 2 plus 1 is 3.
3.
You're going to have 3 hydrogens and OH. And this guy is called methanol. Right? What if N is 2? How many carbons do you have?
Could you draw it out for me?
No. When N is 2, because you need to learn this. And right, when N is 2, how many carbons do you have?
2 carbons.
Good. How many hydrogens?
3 at one side and 2 at one.
Total.
3, 4, 5.
Good. And the OH. This guy is ethanol. Right? When N equals to 3
3 carbons.
and hydrogens,
7.
6, 7?
Yeah, 6, 7.
And so this guy is. How does the name of a 3 carbon compound start?
Methanol.
No, we already did that. That's a 2 carbon thing.
Propane.
Not ane, just the
Propane.
prop.
Prop.
Yeah.
So prop anol, right?
Yeah.
And then when N equals to 4,
4 carbons.
hydrogens,
3, 2, 2.
use the formula, Serbia.
9.
Yes. And how do we name a molecule that has 4 carbons?
Butanol.
Good. So you got the bute, and then you add the anol. Right. So for an alcohol, the suffix of the name is going to be anol. Right. So whatever number of carbons you have, you can see meth anol, eth anol, prop anol, right? Bute anol. And so that's the suffix you're going to use for the naming. Right. If it's 5 carbons, it will be called.
Repeat that.
If it's 5 carbons, what will you call it? An alcohol with 5 carbons.
Hexanol.
5.
No, I think hex is for 6, right?
Yes, hexanol is 6.
Uh,
Pentanol.
Pentanol.
I thought that's going to be wrong. Okay.
I mean, you're going to be wrong, or it's a 50% chance, so might as well say it.
Yeah.
Okay, right? So point is you end with anol and you add the prefix, which is either meth or eth or prop or bute or whatever.
I'm fine with the suffix, but I only always get confused with the suffix.
Right, now these guys all have melting points below 0 degrees centigrade, so they all have negative melting points, so they're all liquids, at even 0 degrees centigrade, and their boiling points are also relatively low, right? Methanol boils at 64, ethanol at 78 degrees centigrade, propanol at 97. Butanol is slightly higher than water, 117 degrees centigrade. This is given. Now, if I'm not writing something on the whiteboard, I mention it's in your book, you read the book and you get the information, okay? Don't skip it.
Okay.
So they mention that, oh, isomerism.
Say that again. Say what?
Isomerism.
Okay, that's a hard thing to pronounce.
Isomers. They're going to make isomers out of these guys, right? So we have this guy. I'm not drawing the hydrogen, seriously.
Isn't
Right?
that the same thing that we just did?
What is this molecule called?
It has 3 carbons.
Come on, come on.
Yeah, Haram, go on. You can do this.
Yeah, she gave it the last time as well. Come on, Sobia.
Uh, we should do it. We should name them according to the carbons, right?
Yes,
Ethanol.
that's two.
Uh, what was 3? Wait, it is not butanol, right?
That's four.
I'm missing the third one. Uh, it can't be pentene, would it?
No, it's not the shampoo.
Yeah, it's not the shampoo. It's not hexanol as well.
It's propanol. Okay. Right. So this is propanol. Then we've
Yeah,
got this guy, right? And you have,
that's also propanol. It has 3 carbons.
now what do we do? Right? Yes, these are both propanol, but in this case, these are isomers. Why are the isomers? Because just like we did with the alkenes and the double bond not being at the first carbon, we just did that yesterday, remember?
Yeah.
And so the functional group is the OH, the hydroxyl group, and so the hydroxyl group is not on the first carbon now. We know that both of these are propanols, but how do we name them? Now recall what we did yesterday and give me names for these guys.
We will do numbering on them.
Okay, so what's the carbon number to which the hydroxyl group is attached in the first molecule?
Wait. We'll start to the side which is closest,
Yeah, and that would be the right or the left.
right?
Right, so this is 1, and then 2, and then 3. And so which number do we include in the name?
The first carbon.
The carbon to which the functional group is attached.
Yeah.
Right, and so the name for this guy will be propan 1 all. Right, not prop 1 anon, right? So not like that, but propan 1
One.
all.
Okay.
Right, and so by that, what will we call this guy?
It's closest to both sides, so we can start from either left or right. It's on you.
Number it right from both sides. 1 2 3, 1 2 3. So in either case you're getting carbon number 2,
Yeah.
right? So what
Yeah.
would you call this? What would you name it?
Ethanol.
How is it ethanol?
Ethanol is okay. Wait.
Ethanol has 2 carbons. This guy has 3. I just said that both of these are propanols. But what?
Propan
Yeah.
2 all.
Yes. Yes. Let's do another. Well, actually, the other way. Right, it's a 4-carbon alcohol. What is it called?
Butanol.
Butanol. Right, and then you've got this guy. Right, this is also butanol because it has a hydroxyl group as its functional group, and it's a 4-carbon molecule. Right, so this is also butanol. What would you
But
what would you name the first one?
Uh, butan. Butanol.
How did you get the one?
Like we have started from like the right side because it is closest to the functioning one.
The
Active.
the right side or the left side?
Sorry, the left side.
Yeah. So the left side is closest to the functional group, and so the carbon to which the uh, functional group is attached, that is the carbon number I'll include in the name. So this is butan 1-ol. What about this guy?
Butan 2-ol.
How do you know that?
Like because it is the closest to the functioning group.
Right, so I number it just to be sure, I can eyeball, I can see it, right? I don't technically like, I don't need the numbering, but just to be sure, I number it left to right, and I get carbon number 2 as the one that has the functional group. I number it right to left, and I get carbon number 3. What do I do? Right, whichever is closest, right? So the lowest number, and so in this case, right, the numbering coming from the left to the right gives me carbon number 2. So this is the one I will use, and so that will give me butan 2-ol. Okay, let's make this a bit interesting. You want to make it a bit interesting?
you mean a bit harder?
Interesting.
Yeah, interesting is much harder.
What is this molecule?
Isn't this also butane?
No,
Because it has 4 carbons.
no.
Like, do we have to break it up?
You okay? So recall. What is the longest chain you're getting out of this? How, like, the longest, like the maximum number of carbons in one go?
Second,
Hmm?
two, oh,
I'm,
three,
I'm not asking which carbon the functional group is attached to. I'm asking what is the longest carbon chain you can get out of this.
three.
Sobi, are you following?
Yeah.
Okay. So I can count from here: 1, 2, 3. This is the longest chain, right? Straight chain. Or I could go 1, 2, 3. Now, if it's bending, the bend doesn't matter. Is it straight? Is it in continuation? It
Yeah.
is, right? So 1, 2, 3. So either case, whether I count straight or whether I take the
It's
bend,
giving us 2.
it's coming as 3. So let's take it as, let's keep life simple, right? So there's 3 carbons as a straight chain. So the name of the molecule will depend on the longest chain that you have. So it's a 3-carbon chain. What's the name going to be?
Propanol.
Okay, so I know it is some sort of propanol molecule. Now, second, to which carbon is the hydroxyl or functional group attached?
2.
Second.
Carbon number 2 again, right? For that, now this time I counted again, right? Because I'm giving you an easy one. This could be a different molecule. So I counted again. 1, 2, 3. Is it the same going the other way? 1, 2, 3. It is the same, right? So okay, fine. This is propan
2 all.
2-ol. We're not done. What about this guy? This is a side group, remember? When we
Yeah.
talked about
Yeah.
structural isomers, this is a side group. Which carbon is the side group attached to?
2.
Functioning.
Which carbon number is the side group attached to?
Last.
Haram beta. Carbon number 2, isn't it?
Yeah.
Right? So this is going to be 2 something propan 2 all. Now what is that something? How many carbons long is the side group?
3.
The side group beta, not the main chain. The side group, the one I've circled.
1.
1, right? You seem confused.
I am.
Okay, the side group is the carbon or whatever is attached, right? The, that is obviously not part of the main chain, right? We just counted the main chain. We said, okay, fine. The longest chain that we have is 3 carbons. We went left to right. We just took the straight chain. We said it's propanol because it's 3 carbons. That would make this carbon sticking out over here as the side chain.
Yeah.
Okay, it's just
Yeah.
not. It is not part of the main chain. It is not part of the propanol, like the prop part, right? It's not. It's extra, so to speak, right? So which carbon number is attached to? It's attached to carbon number 2. So I put 2 over here. How many carbon atoms long is the side chain? 1 carbon
1.
atom, right? And so what is the name that we use? Like how do we name a 1 carbon molecule?
F.
Meth. And
I'm
so
sorry.
yeah, meth. And so we're going to name this 2-methyl, right? 2-methyl is talking about the side group, and then propan 2-all is the main molecule. Had fun,
Yeah.
right? Now it's not going to get any more complicated, right? But just to give you an idea, like you can have all these kind of isomers. To keep it simple, again, right? I'd say this is not give. It's not given in the book like this. You may not come across it, right? I just did this to give you an idea. Uh, so we'll stop there, and then right, the next time we're going to talk about reactions. Okay,
Yeah.
Okay.
right. So you've got combustion reactions and oxidation reactions for ethanols, and then how ethanol is manufactured, and some other reactions. And then after that, we've got carboxylic acids. So, right, this chapter might take, it's definitely going to take 2, maybe 3 to 4 classes, depends on how, right, we're able to cope with it. So, yeah, maybe the next 2 weeks, a week and a half, definitely, maybe 2 more weeks from now, and we'll be done with organic chemistry as well. But I do highly urge you to follow along with the book and do practice questions from the text, from the workbook. And if you have topicals, you can start with those, right?
Okay. Yeah.
Any questions?
No.
All right,
Mm.
then I'll see you guys next time, inshallah.
Okay then. Allah Hafiz.
Allah Hafiz.